Welcome to IM1's 11.4, video number 1 of 2, and the topic here is congruent transformations, and we have 5 boxes to discuss for this video here. So box number 1 is asking us or wanting us to understand how to identify a congruent figure. So you should recall that congruent lines and line segments, like we've studied before, means they have like the same measure or the same length. Congruent angles have the same angle, like 45 degrees is congruent to 45 degrees. So when you hear the word congruent, you should automatically be thinking something's going to be the same. So congruent figures have to have two things. They have to have the same size and they have to have the same shape. Okay? So for example, like a penny and a nickel, those have the same shape, but they don't have the same size. So they're not congruent. And more importantly, there has to be at least one rigid motion that maps one figure onto the other. So remember that a rigid motion is these things that we have been studying, such like a translation or a reflection or a rotation. So something that preserves all the angle measures and all the sizes of all the sides. So here's some quick examples for you. These shapes over here, these 3 shapes right here that I'm highlighting for you, these are all congruent figures. The reason is because they all have the same shape and they all have the same size. But more importantly, I could map this figure onto this figure with a rotation and a translation. I could map this figure onto this figure with a reflection and maybe like a translation. Okay, so all 3 of these are congruent because they have the same size and the same shape, and there is at least one rigid motion to map from one figure to the other. These over here are not obviously congruent because number 1, they're different sizes and there is no rigid motion. So like this one trips up students a lot. So notice like this little blue triangle and this little blue triangle, they definitely have the same shape, right? But they do not have the same size. So you have to have both in order for them to be congruent. So congruent figures over here, not congruent figures over there. That's everything for box 1. Okay, box 2, let's walk you through this example of identifying congruent figures. So I have 3 sets here of congruent figures, and they're color-coded for you. So let's take a look at the square. So I have square NPQR over here in yellow for you. And then I have square ABCD over here. So they definitely look congruent. In fact, all of these are congruent. And first of all, check and see, does this square and this square, do they have the same size and the same shape? Yep, they do. Same size, same shape. But more importantly, how do I get this square to this square using rigid motions? Well, if I look over here, there's a translation that's happening, right? I can go 2 units to the left and then 6 units down. So I could take this square and go 2 units to the left and 6 units down, and then I would end up with this square. So therefore, these 2 are congruent because they're the same shape and size, and there's a rigid motion to map this figure onto this figure. Okay, same thing, let's take a look at the orange ones here. So I've got triangle KLM over here, and I have triangle FGE over here. And they have the same size, they have the same shape. One just looks upside down of the other. That's because there's a reflection happening. So that's my rigid motion. So I'm reflecting it over the x-axis, and that's exactly what it says right here. So I could get this figure to this figure with a reflection over the x-axis. And then lastly, I have the green triangles over here and over here. All right. And triangle STU and triangle HIJ, they definitely look like the same size and same shape. And more importantly, how can I get this figure to look like this figure? Well, there's a rotation happening, another rigid motion of 180 degrees. So if I map my rotation 180 degrees, I would end up, right there, that one. That'd be 180 degrees this way, so 180 degrees. I can map it that way. And rotation, we know, are rigid motions. So that's what we're looking for when we identify congruent figures. Okay, here's box 3. There's a new term that the book introduces at this particular point. It's called a congruence transformations. So the definition for us just means congruence transformations is interchangeable. So this little arrow here, it means it's interchangeable. That means it has to have at least one rigid motion. So nothing really new here. We're just going to say that a congruence transformation guarantees that we have at least one rigid motion that we can map from one figure to the other. Okay, so let's take a look at box number 4. It says describe a congruence transformation that maps quadrilateral ABCD onto EFGH. All right, so I am trying to get this quadrilateral here to map onto this quadrilateral here. All right, and it wants me to do a description of that. So I have to think, how can I get this figure here to look like this figure over there? Well, the first thing that you can do is, I'll do it in like different stages for you, is sort of do a reflection over the y-axis. So if I reflected the figure, this original figure, over the y-axis, then that would give me, that would change the direction of the slants of my shape. So I could put a point here, that'd be a reflection, and then that would be my A prime. Then I could do B if I count again like normal, right? So 1, 2, 3. If I count, I can go 1, 2, 3. So that would be my B prime. Okay. If I count the reflection from D, so 1, 2. So I'm gonna go back 1, 2 over there. So that would give me my D prime. And then lastly, C prime would have to go here just through everything that we've been working on. So this figure right there is a reflection. And now it's starting to look like the GH and EF down below. So then how do I get it down? Well, looks like all I would really have to do is translate this guy down 4 units. Translate that guy 1, 2, 3, 4 units. Translate that one 1, 2, 3, 4 units. And then translate this one 1, 2, 3, 4 units. And that would get me to that spot, and it'd be a rigid motion. So when it says describe a congruence transformation, what does that mean? That means this sentence frame right down here. So a congruence transformation that maps quadrilateral ABCD to quadrilateral EFGH is a reflection. So we did a reflection in the y-axis, okay, followed by a translation. Followed by a translation, looks like 4 units down. 4 units down. All right, so when it says to describe the congruence transformation, what it wants is this statement right here in the purple cloud. That's what it's looking for when it says describe the congruence transformation. All right, that's box 4 for you. Okay, last box, box number 5, it's a U try. So it says describe a congruence transformation that's going to map triangle JKL to triangle MNP. So go ahead and think about it real quick right now. Okay, hopefully you see what was going on here. There are 2 things that are going to be happening. Number 1, if I reflect JKL over the x-axis, you would see that I would get this shape here. So I would go 2 units down, and then again 2 units down, and then for K it is 1, 2, 3, 4. So 1, 2, 3, 4. So I would get this shape here. All right. So that'd be a reflection. So the first one would be a reflection. So a reflection in the x-axis. And then followed by, it looks like if I, how do I get this point over here? So I'd go 1, 2, 3, 4, 5, right? And then 1, 2, 3, 4, 5. So followed by a translation. 5 units right. Okay, and that right there is how we describe the congruence transformation. All right, that's everything you need for this first video lesson. See you in the next one.